Okay, so 2.5, this is the last section in chapter 2. And it's on solving inequalities, but it's on solving inequalities that have exponents higher than 1. So like quadratic. So I'm going to give you a formula. I think we did this formula before, but I'm going to put it up again. And this is the formula that gives you the height of an object based on how much time it's been in the air for projectile motion. Okay, just a couple reminders what some of these are. So the negative 16, that's a constant. We just leave that the way it is. T is the amount of time that the object has been in the air in seconds. V sub 0 is the initial speed of the object when it was launched. Okay, S sub 0 is initial height. And then this side of the equation tells you how high the object is. So initial height would be like if you threw it off of like a building. The ball wouldn't be starting on the ground. So let's use that formula and try an example of projectile motion with an inequality. So we're going to see like greater than or less than in that spot. Okay, we're going to use the graphing calculator. That's why I took those out to kind of help us with some of these questions. So let's say that we have an object or a ball being thrown straight up from ground level. If something's ground level, what's the initial height? Yeah?
0.
0. So I'm not even going to need the initial height in this problem. So that's going to make it a little simpler. It's just going to be a plus 0. And the initial speed is 80 feet per second. So we know the ground level means 0. Where would this 80 feet per second get plugged in? Yeah. Initial velocity. So let's set all that up. So let's plug in my values from the problem into the formula. Okay, so they're not asking us to do anything yet. I'm just taking the numbers they gave me, plugging them into the formula, so I'm ready to use it to do something in the next step. So the question is, when is the ball at least 64 feet off the ground? What would that mean as an inequality? At least. That's not really one of the names of the 4 symbols. I want to translate that to a symbol. Yeah?
More than or equal to?
Yeah, more than or equal to. Yep. Okay, so let's graph the original problem. Negative 16x squared plus 80x. And they want to know when it's how many feet off the ground?
64.
64. So we're going to put a line at 64. Is the standard window going to work here? Negative 10 to 10? No, because negative 10 to 10, it's not going to let me see all the way to 64. Also, x represents your time. What's the smallest amount of time that could go by in this problem? Yeah?
0.
0. You can't have negative time. So we don't need negative on the x. X max is how long the object is in the air for. I don't know that yet. I'm just going to leave it at 10. Y is the height of the object. What's the lowest height that this object could have? Measuring it off the ground. Yeah?
0.
0. It can't go lower than 0. Highest height, I don't know that. But I do know I want to see at least a 64. So I'll go to 100. Okay, and when I hit graph, Well, I didn't go high enough. Or I didn't type in the problem. Sometimes I type it in wrong. Negative, oh, yeah, what did I forget?
Negative.
Yeah, I just forgot the negative, that's all. I mean, that makes a big difference, but it is negative 16x squared plus 80x. All right, let's try it out. That's a lot better. Okay, so I want to figure out when the height of the ball, which is in the blue picture, when is that above the red line at 64? So what do you think I'm going to have to find in that picture? I'm going to use the calculator to calculate something. Yeah?
The intersection.
Right, I need both intersection points. And then we'll go from there. Okay, so let's do the one on the, well, I'll just do intersect. If I just hit enter 3 times, it'll give me one of them. Okay, so that's the one on the right. And now I need to be a little more careful to do the one on the left. Just move your cursor further to the left. And now you should be okay. Perfect. Okay, so I've got each intersection point. So based on the 2 intersection points, at what time is the ball 64 feet or higher? Yeah. Ben?
After 1 second, is that?
Okay, so after or equal to 1 second. And yeah,
Before 4 seconds?
before or equal. Yeah, so it's between 1 and 4 seconds. Before 1 second, it hasn't gone high enough yet. After 4 seconds, it's already on its way back down, and it's under 64 feet. So when is the ball at least 64 feet off the ground? Between 1 and 4 seconds. And technically, you can include the 1 and you can include the 4 because at least means that number or higher. Okay. So what we basically just did is we solved this inequality. We let the height be 64. That's what we used as the horizontal. This was the formula. And we wanted to figure out when the graph in blue was above or equal to 64. That's what we just solved. When was the blue above or equal to the red? And we did it graphically. So that's one way that you can solve an inequality that has a higher power. You can graph it. Usually you use y1 and y2 and do an intercept. Okay. Let's look at another one. So this is the same data as the first problem. So it's same numbers. How long is the ball in the air? We got to think about that in terms of the height of the ball, because that's the only formula we have. What do we know about the height of the ball if it is in the air? Yeah?
It's above 0.
It's above 0. So that's the question they want us to solve. When is the height above 0? So first we got to go back and look up the formula that represents the height. That is negative 16t squared plus 80t. Okay. So when is that above 0? All right, let's see if we can solve this one without the calculator this time. What does the first term and the second term both have in common? Yep.
T.
Yep, they both have a t in common. So I'm going to factor that out. I also want to factor something else out. Is there any number that they both have in common?
4.
They do have a 4. I'd like to, let me clarify, factor out the biggest number
8.
they both have in common. I agree they have 8 in common. 16. So they both have 16 in common. I'm also going to factor a negative out with it because you'll see why in a second. If we factor out a negative 16t from this first term, what would be left inside the parentheses? So when we distribute back out, we get negative 16t squared. Yeah.
Would just be t plus 5.
Yeah, this would be a t. Well, that would be a t. And then what would you need here? Just think of the signs first. A negative times a what is a positive? Negative times a negative. So we definitely need a negative. And what number times 16 gives you 80?
-5.
Yeah, the -5. Okay, so now look at what's happening here. You've got 2 factors. That's the first factor. That's the second factor. What did we say earlier about t when we set up the window? What's the smallest amount of time that can go by in this problem?
0 seconds.
0 seconds. So can t ever be a negative number?
No.
No. So if t is not a negative number, then that means t is it's going to be a positive number. So this value that I'm pointing to is always a positive. If you take a value that's always positive and multiply it by negative 16, what kind of answer do you get? You're going to get a negative. So no matter what you plug in for t, it always has to be positive. And a positive times negative 16 means this entire first thing is always going to be a negative. Is there any question why this is negative? Now, look at what has to happen. A negative times a something has to come out bigger than 0. What has to be here if it's a negative times a what is going to be bigger than 0? Yep.
Just be negative.
This also has to be a negative. That's the only possible way that you could end up with a positive answer. Because the first one is definitely negative. So you got to figure out what would make the second one negative. And then a negative times a negative is going to be bigger than 0. So now we've turned this question into something a little simpler. All we have to do is figure out what makes this second factor negative. So when is t minus 5 going to come out to a negative number? Because as long as it's negative, a negative times a negative will be bigger than 0. And how would you solve that? Yep, add 5 to both sides. And what do I get for an answer?
T is less than 5.
T is less than 5. So how long is the object in the air for?
Less than 5 seconds.
Less than 5 seconds. Yeah, so it's like 4.9 repeating. What happens at 5 seconds?
It's round.
It's back on the ground. Yep. And you can see that if you look back at the graph and you go over to 5. It's back on the ground. Okay, so the ball is in the air just under 5 seconds. Okay, so thinking about the idea of when a factor comes out negative or when a factor comes out positive is the idea of what's called a sign pattern. You're figuring out where something is positive or negative. Yeah?
Could you also find what time it hits the ground by just finding the 0 to the 0?
Yeah, you're basically finding the roots there. Yep, exactly, yep. So what we just had a minute ago, t minus 5, that's called a linear factor. If I write something like this, that and I factor it as x plus 2, x plus 3. X plus 2 is a linear factor. X plus 3 is a linear factor. What makes it a linear factor is the exponent is now a 1. So factoring is a way to turn a quadratic into 2 linear factors. And that's what sign patterns are going to be based on, factoring. So every linear factor has a single number that you can plug into it and make it 0. What number could you plug into x plus 2 and that would come out to 0? Yep.
-2.
-2, and that is the only number. What number could you plug into x plus 3 and make that come out to 0? Yeah,
-3.
-3. Here's another example. T minus 1 and t plus 4. If you plug in 1 for the top factor, you get 0. If you plug in -4 for t in the bottom factor, it simplifies to 0. So the biggest thing with a sign pattern is, first of all, can you find the factors? Because I'm not going to give them to you like that. So you're going to have to find them. And then, can you find the number that you fill in for the variable to make it 0? Those are the two things you have to know how to do with a sign pattern. So once we have that figured out, okay, once we figured out our factor, and we figured out the number that we can plug in to get 0, we're going to make a number line. The number line, it's more of like a visual, so that we can kind of remember what's going on. So we're going to make a number line. And in fact, let me do it for t minus 1. Draw a number line. Mark the 0 on the number line. So in this case, the 0 is 1. So I'm going to put a mark at 1. And I know that if I plug in 1 for t right there, what do I get for an answer? I get 0. What if I plug in a number this way, smaller than 1? So think of a number smaller than 1 and fill it in for t right there. What kind of answer will you get? Yeah, you will get a negative. So numbers in that section give you negatives. Now think of a number bigger than 1 and fill it in for t right here. If you plug in a number bigger than 1, what kind of answer will you get? Yep, a positive. So what we're doing is we're drawing a number line. We're marking the number you plug in to get 0. And then we're breaking it into the two sections and figuring out which one is which. It's not always negative on the left, positive on the right. That could switch if I did something like this. If I put a negative in front of that t, that reverses everything now. If you plug in numbers below 1, you'd get a positive, and above 1, you would get a negative, right? Because that changes everything with the signs. Okay. So that's the idea of what I mean here. Make a number line, mark your 0, and determine the sign in each section. The sign is either negative or positive. Kind of a hint, a lot of times, if this letter is positive, then negative will be on the left, positive will be on the right. If this letter is a negative, it's going to be reversed from what I just said. Right, so let's try it up to that step. Okay. Leave, I would say, however much space it took you to write that, leave about that much space below that, and then start your example. Because there's one more thing I'm going to write, but I want to make sure this is okay first. Okay, so I'm going to come back to that in a second. let's try this one. So the goal here is to solve this inequality, but it's a quadratic, it's not linear. So we can't do it the way we did yesterday. And you can't use quadratic formula on a linear inequality and get the signs. Okay, so in order to do a sign pattern, you have to be able to factor it. If you can't factor it, this whole method goes out the window. Can't do it. Okay, what would be my first term in each set of parentheses to factor that? Yeah, an x, and what else? 2x. A 2x. I have a positive in the middle. I have a negative for my constant. What does that mean my signs will be? Yeah.
2 negatives?
I can't do 2 negatives, because if I had negative times negative, that would give me a positive in the end.
Positive and a negative?
Yeah, I need a positive and a negative. I would probably try them in that order. If you get that wrong, you can always switch them. But it's nice to get it right so you don't have to waste time fixing it. So let's do it in that order. And now 2 numbers that multiply to give me 5. Yeah?
5 and 1.
5 and 1, and I'm going to do them in that order. Let's check it. 2x times x is 2x squared. 2x times 5 is 10x. What's x times negative 1?
Negative 1x.
Negative 1x. And if you have 10x and you take away 1x, do you get 9x? Yeah, perfect. And we factored it correctly. So that's the first step. You found the factors. Now you want to make a number line for each one of them. We're going to mark the 0 spot on each number line. So what number could I fill in for x? Right where I'm pointing. That would give me 0 when I do this out. Yeah.
Negative 1.
That'd give me negative 2 minus 1. That'd give me negative 3. Yep.
2 times a half.
Yes. If you plug in 1/2 for x, 2 times a half is 1. And 1 take away 1 is 0. So 1/2 is the 0. Yep. Okay. How about in the one below it? What number could you plug in for x right there?
Negative 5.
-5. Okay. Now I just want to figure out what happens in each section. In the top one, pick a number lower than 1/2 and fill it in for x. What kind of answer will you get if you plug in a number below 1/2?
A negative.
Yep, you'll get a negative. And what if you plug in a number above 1/2?
Positive.
Yep, you'll get a positive. Okay. Now look at the bottom one. What if you plug in a number below -5?
Negative.
You'll get a negative. What if you plug in a number bigger than -5?
Positive.
You'll get a positive. Okay, so we've broken the number line up into its negative and positive sections based on the root. Okay, now the last thing. We're going to put these 2 number lines together. So once you have the sign pattern, that's the number line, for each individual factor, we're going to combine them together now. Whether we're looking at a product, which in this case, we're doing a product of 2 factors, or a quotient, like a division of 2 factors, it's the same process. Only thing with division is you want to make sure you don't ever divide by 0. So that can affect your answer. But with products, that's not an issue because you don't have any fractions. So let me show you how we combine the two number lines together to get our final answer. And then we'll pause at this one. Does everyone have that top part? All right, so when we put them together as one number line, mark both spots on the same number line. Let's put -5 here, and let's put a half over here. Now we've got 3 sections, the left, the middle, and the right. Let's look at what happens if we are below -5 in both my number lines. Okay. Let's start with the top number line. If I am below -5 in the top number line, what section does that put me in? Puts me in the negative section. What if I am below -5 in the bottom number line? What section does that put me in? That's also negative. So I'm in the negative section for both, and if I multiply a negative times a negative, I'll get a positive. So if you pick a number below -5 and plug it into this whole thing, you'll end up with a negative times a negative. Okay. Let's look between -5 and a half. In the top number line, what part am I in if I'm between -5 and a half?
Negative.
Yeah, I'd be like somewhere in here. I'd be in the negative section. How about the bottom number line, between -5 and 1/2? Yeah, that would put me somewhere in the positive section. And if you take a negative result and multiply by a positive result, you get a negative. Yep. And the last section, bigger than 1/2. What if I am in the top number line, bigger than a half? Where am I? I'm in the positives. How about the bottom number line? If I am bigger than 1/2,
Positive.
I'm in the positives. And if I take a positive result times another positive result, I'll get a positive. As a hint, it usually alternates negative, positive, negative, or positive, negative, positive. Okay. Now we just have to write the final answer. The question was asking, where are you greater than 0? Does that mean positive or negative? That means positive. How many sections in the final answer are greater than 0? 2 of them. This one and this one. What's the lowest that this first section goes? How low? Yep, goes all the way down to -infinity. And what's the highest that it goes? Goes to -5. Can I include the -5 or not include? Not include. It says greater than. There's no equal to. Or the other answer is on the right. What's the lowest that the section on the right goes? Goes all the way down to a half. Can I include it? No. Same reason I couldn't include -5. And what's the highest that that section goes? Infinity. So you can pick any number that's lower than -5 or higher than a half, and it will answer the original problem. But that's the process of a sign chart. Okay, so we'll do another one, but let's pause there. Okay, so the next problem has 3 factors, but it's already factored for you, so you don't have to figure out what the linear factors are. So they're x, x plus 3, and x minus 1. So we're going to mark, doesn't matter where you put it, you're just marking a spot on each number line for the root. And we're going to find out what they are. Okay, what number could you plug into that first factor that I have parentheses around? And when you do it out, it would come out to 0.
0.
Yeah, it's just 0. How about the second factor? -3. And the third one? 1. Now we'll test a number on each side of the roots. If you plug in a number lower than 0 for x, you will get a negative. And bigger than 0? Positive. Pick a number below -3 and fill it in right there.
Negative.
Get a negative. And pick a number bigger than -3 and fill it in. Positive. And the last one is also negative positive. Again, as long as that letter doesn't have a negative in front of it, it's usually negative positive. Okay, so now we're going to put all of that together on one number line, and that's going to break it into several sections. So we've got 3 roots. Doesn't matter where you put them, you just need general sections. -3, that is the smallest, so you do have to put that on the left. 0 is the one in the middle, and 1 is on the right. So how many sections did that break my number line into? 4. 2 bounded, and then 1 unbounded on the left and 1 unbounded on the right. Once you figure out the first section, it usually alternates. So we'll do the first 2, and then from there, we'll just say it alternates. So let's pick a number that is lower than -3. So in the top number line, if you are lower than -3, what part of the number line are you in?
Negative.
The negatives. In the middle number line, if you are lower than -3, you are in the negatives. And in the bottom number line, you would also be a negative. And we're looking at the product of all 3 of those. What's a negative times a negative times a negative give us for this whole result?
A negative.
Gives us a negative. Okay. Now let's look at the numbers between -3 and 0. Okay. In the top number line, if you are between -3 and 0, what part are you in? What is it? Nope, the top number line, between -3 and 0. You're definitely in one or the other.
Negative.
You're in the negatives, yeah. How about in the middle number line, between -3 and 0? Now you're in the positive part. And how about in the bottom number line, between -3 and 0?
Negative.
You're in the negatives. And what would be the result of a negative times a positive times a negative?
Positive.
Positive. And that's just going to alternate. Negative, positive, negative, positive. So now we scroll back up and see what do they want to know. They want to know the sections that are 0 or higher, greater than or equal to 0. How many sections in the final answer are 0 or higher?
2.
2. This section and this section. And remember, this time, there's an equal to. So how would you describe the numbers? We'll call that section 1. How would you write an interval that describes the numbers in section 1? Yeah, go ahead.
X is less than -3.
So we're looking for an interval, so we won't have any letters. But, and less than -3 would be outside of section 1. That would be over there, yeah.
You need a parenthesis and then -3 and then 0 and then a parenthesis.
Okay. Now, when you, what's up, Stuart?
Oh, I don't want to talk. You're really into this right now.
Oh yeah, we're in. So what, now if you
dial,
got,
baby, dial long
dial in.
distance. Tune in Tokyo, if you will.
Yes, we're tuned in. So what You can be equal to the number -3 and 0 though.
Oh, so it would be the bracket.
It would be the bracket, yeah. So that's that section. Or how would you describe the numbers in the second section that are also solutions? Yeah?
So a bracket and then 1 and then comma infinity and parentheses.
Yeah. So in order to satisfy that inequality and have it come out greater than or equal to 0, you could pick a number between -3 and 0, or you could pick a number 1 or higher. Okay, now the sign pattern method, that only works if you can factor it. If you can't factor it, then we'll use the graphing calculator. And the graphing calculator, it's pretty much like we did the rocket problem. It's just finding an intersection. But I'll just go over how to do it. So what we're going to want to do is put what's on the left in y1 and put what's on the right in y2. Okay, so we've got x cubed minus 2x squared minus 5x plus 7. Okay, so that's my y1. And my y2 is going to be 2x plus 1. All right. So x cubed, that one was the one in blue. So we're looking for where the picture in blue is greater than or equal to the picture in red. Okay, so let's see where that happens. Again, this is a cubic, so it would be very hard to factor unless something worked out special, so that's why we're just going to graph it. Okay, I will do zoom 6. And remember, the blue needs to be above or equal to the red. Okay, let's look at that. All right, is there anywhere on that graph where the blue is higher than the red? What do we think? What do you think?
I'll say that little hump that's right there.
Yeah, so the section in the middle. Is there anywhere else where the blue is higher than the red? Yeah.
It's right at the tip after the second curve.
Yeah, right on the right-hand side. So from here to here are answers to this problem. So we need to figure out what the x values are between this point, basically over to this point. So what are the x values in this section? So from here to here. And any x value from here continuing to the right forever. So how am I going to get these 3 points? What do I have to do? How about Calvin? What do I have to do on the calculator?
Find the intercepts.
Yeah, I'm going to have to do all 3 of them. And remember, I'm looking for the x value, because that's the letter that's in the problem. We're solving for x. So let's do intersect. So you can pick x values between negative, I think it's, yeah, negative 2.26. And you can include it because of that. And you can go up to, it looks like it's a little bit less than 1 on the x-axis. But I need to figure out what it is exactly. So go over here. 0.76. So if you pick an x value between those 2 numbers, the blue section will be above the red. Or you can pick a value, looks like it's about like 3.8 3.8 or 3.9 or higher. Let's see. Just move your cursor. That's pretty good. That's 3.5. Okay. So about 3.51. Or anything that's 3.51 and going on forever, because the blue is going to be a lot steeper than the red, because it's a cubic and the red one is a straight line. So that's how you'd solve an inequality where you can't do a sign pattern. Okay. Question on that? Yeah.
Can you do it even if you can factor?
Yeah, you could also check your answer with that. If it says to do a sign pattern, I might ask you, like on the test, to show me the factors, or I might have you type the factors in a box. So yeah, if it says a sign pattern, I'm probably going to ask you to show me something. But yes, you absolutely could check your answer this way. Yeah, you'll just get nice numbers instead of decimals, because it's factorable. All right, so that's it for 2.5. So we're going to take a little bit of a look at 3.1. I'm going to be changing a little bit. So if you look at the video, make sure you do the one from YouTube, because the one on Schoology, it's going to have more in it than we get to. Okay, so first of all, what is a polynomial function? Okay, that's what chapter 3 is all about. Basically things that look like this. That's a quadratic polynomial. Something like this. That's a cubic polynomial. Those are examples of polynomials. The thing that makes it a polynomial is the exponent is a non-negative integer. So when you look at the exponent, you got a 2, you got a 3, you got a 2. The exponent has to be a number that is not negative. And it has to be an integer. This is not a polynomial. No. That has a negative exponent. That is not a polynomial. Something like y equals x to the 3.5 minus 4. No. Not a polynomial because it had a decimal exponent. So no decimals and no negatives for the exponents on the variables. Also, all the coefficients are real numbers. Like 1, -8, +3. You could not have something like this. 2i x squared minus 5x plus 7. 2i is not a real number. That's an imaginary number, and you cannot have an imaginary number in front of a variable and call it a polynomial. So no, that's not a polynomial. So any question on, especially the ones that I crossed out, why those are not polynomials? Okay. So let me do it like this. The term with the highest exponent gives you the degree. Okay, so there's something called the degree of the polynomial. So the term with the highest exponent gives you the degree. Some degrees have special names. Those ones are the ones that are most common. So something that's linear. It's like y equals mx plus b. look at the term with the highest exponent. Well, if you ever don't see an exponent on a letter, the exponent is always what number? Yeah, it's always a 1. So that's a linear polynomial. If something's quadratic, what would be the highest exponent? It would be a 2. So something like 4x squared minus 6x plus 7. This polynomial has a degree of 2. And if something is cubic, the degree is 3. Let's do 5x minus 4x cubed plus 6. Now, when you look at that one, if you look at the first term, you might say, wait a minute, the first term's linear. I didn't say anything about the first term being the degree. I said the term with the highest exponent. If you write this in what's called descending order, then yes, you should put the term with the highest exponent first. You shouldn't put it in the middle like that. But technically, that is a degree 3 polynomial, because the term with the highest exponent is a 3. Any questions on that?
So the highest exponent determines the degree.
Yep. Yep. Now, the nice thing about polynomials is the two things that could lead to problems with them, they're trying to divide by 0 and taking square roots of a negative. Those two things aren't allowed in polynomials. That means you will always be able to plug in any number you want. There's no number that you can plug in here that would give you an error. You can triple anything you want. You can triple a negative number, you can triple a positive, you can triple fractions, decimals. Same thing with raising something to a power. You can square negative numbers, you can square fractions, positives. You will never end up dividing by 0 when you have a polynomial. And you will never have the square root of a negative. Those are the only two things that could mess up the domain. Now, the range depends. To get the range, we would have to graph it. But is there any question why the domain is all numbers? That's what that means, all real numbers.
Can you repeat the question?
Was there any question why you can plug in any number you want into a polynomial?
Oh.
So cubic, did I skip quadratic? We've looked at quadratics a lot. Those are like U-shapes. Cubics look like that. This exponent tells you, or the degree tells you, how many times the graph could turn. Right? Or I'm sorry, how many times it could cross the x-axis. Imagine you had an x-axis right there. How many times does that axis cross that graph? Yep.
3 times.
3 times. So that exponent is the maximum number of times the graph could cross the x-axis. Because let's say your x-axis was up here. How many times does that graph cross?
Once.
Twice.
Twice. Yeah, it just comes and touches it. That counts as a root. And then it crosses it a second time. So that's twice. And then what if you had something like that?
That's once.
That's just once. You can't get 0. 0 is impossible because one end goes down and one end goes up. But you can get 1, 2, or 3. Now think of like a parabola. If you had a quadratic, how many times could a horizontal line cross that? You could get twice. You could get once. It was just like that.
0.
Or you could get 0. Whoops, not if it was up there. But you could get 0 if it was down there. Okay? But that's the general pattern of a cubic. Sometimes it doesn't actually turn and come down and go back. Sometimes it kind of starts to turn, but it just keeps going. Sometimes the turn, it's bigger. That's kind of a small one there, but sometimes it takes a bigger turn. But still the same kind of pattern. Now, a fourth degree polynomial has an extra term in it. It doesn't have to have every single term from the exponent of 4 all the way down to the constant. This is a fourth degree polynomial. In fact, it's the simplest fourth degree. It doesn't have a cubed, squared, linear, or constant. It just has 1x to the 4th. But the more terms you add in, the more complicated the shape starts to get. And the most complicated shape you can get for a degree 4 is like a W shape, where it crosses the x-axis 4 times. It could cross 3 if it was just like that. You could get 2 if it was just like that. You could get 1 if your graph was like that. And you could also get 0. So with a fourth degree, you can get everything from 4 down to 0. I'm just trying to kind of show you the general shape. So we'll do that one, and then that'll be a good place to stop. Okay, so it says find the domain and the range. First of all, are there any exponents on the variables that are negative?
No.
Nope. Are there any, what else do we have to look for? Oh, are there any decimal in the exponents? No. So then is that a polynomial?
Yes.
Yes, that is a polynomial. So what numbers are you allowed to plug in for x?
All real numbers.
Anything you want. You can plug in any number you want. And let's find the range. Okay, so range, we're going to draw it. You don't need any parentheses because this is not a fraction, so just type it in the way you see it. 5x cubed plus 2x squared minus 8x plus 1. Okay. I'm going to do zoom 6 and just kind of see how that looks. Should probably go a little lower. So if you haven't already graphed it, I would do your y max maybe negative 20. Or y min. Sorry, y min. Okay. So first question, how high does it look like this shape is going to go? Yeah, it's a W shape, and the two sides are going to go up forever. Does it look like it goes down forever? No, it stops right about here. If I want to find how low that point goes, this is the y value, okay, how low, how far down, because it's range. Which option do you think I would use in that list? Minimum. So when you do minimum, it asks you 3 questions, like a lot of the other things. You pick a point that you know is to the left of your minimum. You pick a point that you know is to the right. And the guess, you just put it pretty close to the minimum. And what is the lowest that graph is going to go on the y-axis?
Negative 12 not included.
Let's round to 2 decimal places.
11.95.
Negative 11.95. And you can include negative 11.95 because we do hit it. I can see I hit it if I round that number off. So that's fine.
So you can include it?
Yep. I can tell that we hit it because I calculated it, and I can see that number, negative 11.95. It's right there.
Oh,
It's rounded, but it's right there. So that's how you find domain and range. So we didn't quite finish, so I am going to change the homework a little bit. We were very close to finishing. Okay, the first page, that's fine. That's the sign pattern problems. Actually, hold on, I might change one there too. You 20, 22, 28, 16. Oh, I guess I already took out what I was gonna. All right. So actually, so we're gonna do that on the first page, and then on the second page. We're going to do, let's say, change that completely. Let's do 1 through 5. And I'm going to change the directions. Find the domain and range. So you will need the calculator to do that. Okay, and we got a little bit to finish up on that. We'll look at that tomorrow.